Hello everyone, welcome again. Today we will learn about the RTC or real time clock and how we're going to connect it to the MCU, which is the Arduino. Okay, the one we're using today is called the DS1307. This one is a real time clock. Okay, we can retrieve the seconds, minutes, hours, date of the month, day, and also can go to week of the year, and also can compensate the leap year up to 2100. Okay, this is the pin out of the package. It's got 8 pins. Okay, and also got the advantage of automatic power fail detect, and also switch the circuitry to the secondary battery backup in case the main VCC is down, and also very low power consumption of up to 500 nanoamp based on the power consumption from the battery backup. Also, it's available in 2 packages of 8 pin, either DIP or SOIC. Okay, and the pin out, as we can see here, got X1, which is the X1, X2, which is the oscillator input. VBAT, this one connected to the backup battery, ground, VCC is the main input VCC. This pin number 7, which is square wave generator output, and also SCL and SDA for control and data signal. Okay, here's more description about the pin out. Okay, so from the data sheet, you guys can go through, but the most important thing you have to understand and focus on is this. Okay, so from this control register, we can set the square wave output, the one we mentioned just now, by setting these 2 pins, the RS1, RS0. Okay, if the RS1 equal to 0 and RS0 equal to 0, it will output 1 Hz, and etc. until we can get 32 kilohertz when we set RS1 to 1, RS0 to 1 also, according to this table. Okay, and this is how we connect the RTC, the DS1307, to the main MCU or the main microcontroller unit by using 2-wire configuration. Okay, using the SCL and SDA. Okay, only 2-wire connect to the microcontroller or to the MCU, but we have to use 2 pull-up resistor to the VCC. We have to use these 2 pull-up RP, which is about 10k ohm. Later we'll see when we do the wiring. Okay, and also what else? This one, no need to worry about the data transferring method between the chipset with the R2C and also the MCU, because this one all will be covered by the library we'll download later. Okay, this all no need to worry about, but if you want to understand, you can go through. Okay, from here we come to the recommended voltages that we can supply to the chip. Usually we supply with 5 volts, so it doesn't support 3.3 volts. And yeah, if you want to send a logic one, the voltage should be between 2.2 up to VCC, and 0 will consider it from 0.3. Okay, and the V battery, the backup battery should be around 3 volts for the backup battery. Okay, and here's the consumptions for your reference. Okay, that's all. So let's move out to the bench to see how we do the wiring. Okay, so just before we go to the bench to wire up the circuit, I want to show you the full complete diagram of the circuit. So as we can see here, this is our main IC, the RTC, the real time clock. Okay, this is the 8 pin, as we say just now. Pin number 1, pin number 2, which is X1, X2, go to the 32.7 kilohertz. This is the oscillator. Pin number 4 will go to the ground. Okay. Pin number 3 will connect to the positive of the battery, and the negative battery again connected to the ground. This is the coin cell backup battery. Pin number 8, VCC, for sure go to the VCC, 5 volts. SDA and the SCL, pin number 5 and 6, they both are tied to the VCC using a 10k ohm resistor. This is a pull-up resistor to the VCC. Okay, we use 10k ohm, and at the same time we tie them up to A4 and A5 of the Arduino for the communication. Okay, where the SDA for the data we connect it to A4, and the SCL for the clock we connect it to A5. Okay, and the VCC for sure connected to the VCC, and the ground to the ground. VCC will connect it to 5 volts, and also the ground to the ground. So okay, so this is the main circuit we have to follow when we do the wiring on our breadboard later on. Okay guys, so as you can see here, this is the wiring for the RTC, or real time clock. So we start from here, pin number 1 and pin number 2, as you can see here. Pin number 1 and 2 to this oscillator, then pin number 3 and 4 to this coin cell battery. I have soldered this. I have all coin cell holder and coin cell battery, 3 volt. Positive pin number 3, negative pin number 4, and at the same time the ground go to the Arduino ground. Okay, this is Arduino ground. Pin number 5 and pin number 4, they go to the VCC by using these two resistors. This is pin number 4. Pin number 4, pin number 5, also the resistor go to the VCC, which is pin number 1, and also pin number 1 go to the VCC, which is 5 volt. Okay, and pin number 5, pin number 4 go all the way to A4, which is the SDA. Pin number 4 go to A4, which is the SDA. Pin number 5 go to A5, which is the SCL, or the clock. So this is all the wiring. Then we just connect this Arduino to the computer using the USB. Then we can download the code inside and we run our circuit. Okay, so the Arduino will supply the VCC, the main VCC, to the chipset and also the ground. And when it's off, let's say now it's off, the backup battery will make the chip running and continuously keep time for us, giving the time and also the date using this backup battery. However, when the MCU turn on again, it will supply the current to the chip or to the module, then it will automatically recover from the low power mode or from the backup mode. Okay, so again, pin number 1, pin number 2 oscillator, pin number 3 positive battery, pin number 4 to the ground, and all at the same time go to the ground of the Arduino. Pin number 8 VCC, pin number 4 and 5 both got 10k ohm, go to the VCC, and at the same time they will go to A4 and A5, whereby the the fifth pin of the module, this is the 5th pin, because it's 1, 2, 3, 4, this is number 5, the 5th pin of the module, okay, go to the pin, this one, go to the A4, okay, A4 is the SDA, and the 6th pin, so it's 6 pin, okay, this pin number 6, it will go to A5, okay, which is the SCL control, sorry, the clock, not control, clock. Okay, so now we will move to the laptop to do the coding for this circuit. Okay, so now we have reached the software part after we have done the wiring. So I have already wrote the code for you to save the time. So from here we can see that we need these two libraries for the I2C interface, wire.h and RTC lib.h. This library is not pre-loaded in the Arduino IDE. You have to manually add it. Okay, you can find the library, the zip file library online, and after that you just add it to the Arduino library folder by going to Sketch, include library, add zip library, then you go to the directory that you save your zip file in. Then you just call it, then it will automatically add it to your Arduino library folder. Okay, then we need to define an object for the RTC. Okay, for the RTC DS1307 called RTC. Okay, so after we have defined the object for the RTC under the name of RTC, now we come to the setup function. First, we need the serial monitor to display our time or display the retrieved data from the module. Then from here I will check if the module or the RTC is already connected and already physically connected to the MCU. Otherwise, if not connected, it will always print that the RTC module is not fine and also will stuck in this loop. Okay, so this one will not be exit unless you reset again, physically reset your MCU or Arduino in this tutorial. Then it will check again if it's connected, then it will bypass this function or this segment of code. After this, we'll come to check whether the RTC is already running by using this command. If RTC is running, it will check. If it's not running, because we have not here, if it's not running, it will come to the serial monitor and print that the RTC is not running. Otherwise, it can be bypassed if the RTC is already up and running. Okay, now we come to how to update or set the time inside the RTC. Okay, there are two ways to update the time, either by using this format, using rtc.adjust date time, open bracket F date, close bracket, comma F time. This one will take the date and time from the computer, then store it inside the memory of the RTC. Or we can use the second one, this one, to set the RTC to a predefined date and time. Or okay, for example, here we can set to 2014 or let's say 2020. Okay, January 21, and here is the time, which is hours, minute, and second. Then you have to uncomment this and comment this one. And this, if you see this command of updating the date and time into the RTC, you need to perform it once only. So that's why we put it in the setup function, because no need every now and then you do this. You will do it only for one time. Then it will automatically keep the time inside the memory. Okay. Then in the loop, first we redefine the date and time of now, or we retrieve the current date and time at this moment. We call it date time now equal to rtc.now. We take at this moment what is the date and time. Okay, then we store it in now. Then whenever we want to print any parameter, we use now dot the parameter that we want to print. For example, we want to print or want to display the hours, we serial print now dot hour. it will print out our hours. Then we print some spaces. Then if you want to print the minute, we use now.minute. Same goes to the second. So this one will print hours, minute, and second. Okay, same goes to the day, date, month, and the year of the year. I mean the number of the year. First, we use now.day of the week. This day of the week will return the number of the day. Start from the Sunday 0, Monday 1, and so on until Friday, Saturday, until Saturday number 7. Okay, and now.day, it will bring the date of the day. Okay, be careful, don't be confused. Day of the week, it will bring until 7 and reset again from 0. Now.day, it will bring the date of the day. Okay, month will bring the month, and now.year will bring the year. Okay, so now after that we compile again. We shouldn't face any problem. Done, then we upload. Okay, done. There we go. So when we open the serial monitor, now we can see it's updating now. So you can see first it will update. We put it here this side. If we can see from here, first we print our now.hour. So this is the now.hour, which is 15. 15 is mean now around 3. Okay, now.minute, which is 32. This is the minute, and also now.second, which is 45. Then we go new line. We go. You see here now.day of the week 0. 0. Why 0? Because today is Sunday, so start from 0. And then the now.day is the date of today, which is 19, and also the month, which is 7, and 2020 for the year. Okay, so from this we can use this to do we can use it to perform any time counting, timekeeping machine, or also we can use it to generate a timestamp for our data. For example, if you're using data logger to logging some event of our project, we can add a timestamp with this module. Actually, this module we may replace it with the Arduino itself by generating a time. However, Arduino is not accurate to generate the time for you. Plus, after you're resetting the MCU, all your time will be gone. It will always reset again when initialize your variable. However, by using the RTC or real time clock, you will always maintain your current correct time because you're using the, as long as the backup file, as long as the backup battery is connected, so the time and the date will be always there and correct for you. Okay, so now this one, just now we use the we automatically update the date and time from the computer. Now let's say we adjust to our own time by manually set the date and time. Let's say on 2022 January 25th, let's say 3, this is the hour is 3 and 12 minutes and 5 seconds. Okay, so it's uploading now and done. So now if you see, according to our time, we have updated that the hour is 3 minutes 12 and 5 seconds. Actually it's 3 seconds, but it's already passed about, yeah, see, about 3 seconds already passed. We start from here. Here's the 3 seconds. Okay, and we can see here this 2 is mean, because just now we said is 25th January, so 25th is the second day of the week, so is mean 2 start from Sunday 0, Monday 1, So it means Tuesday. So it's Tuesday because 25th January 2021. Sorry, 2022. So here how we can, here's the two way we can update the time, the date and time into the RTC. It will always keep monitoring and also keep updating your date and time for more than, I guess, 80 to 100 years until 2100. Okay, until year 2100. So it's very useful to be added in your next project. So for our next tutorial, we will learn how to make a counter or alarm timer, or we add some more function to our code to make it count the elapsed time, or maybe we do some alarm. Thank you very much and see you soon.